Alright, we are team number 1. Our team name is called CJQ, which stands for our letters of our first name, it being Carlos, Jonty, Juan, and Jose. And our project is called the Feedback Robotic Hand. I'm going to hand it off to Carlos to explain the project now.
Right, our project consists of having the user control the robotic hand, but the concept behind this the user gives the robotic hand gives the user a feedback. So basically, when the robotics will move the robotic hand and we grab an object, the user right there feels what is grabbed. So let me give you a brief demonstration. So, press it. Open, close, open. Assume that along the way we grab an object, so it will close. Also here, the servo here is closed. It's static, so basically, it's limiting the user and it's giving the user some feedback. Assume that the object drops, so both would close at the same time. So also this also serves as a control not to break any object. Assume this is something very, very delicate. As soon as it feels the object, it stops grabbing.
So I mean, basically, we came up with the idea of the actual CD design project. We had many ideas, but we thought that this one was a project that was open-ended in the sense that it had many applications. They go to bomb diffusal, military, waste management, virtual reality, medical, definitely, prosthetics, and basically, I mean, the design in itself is very basic. If you really look at the top of it, I mean, really, all it is it's a human-controlled signal where there's different potentiometers at different points. One being the shoulder, one being here at the bicep. This movement, this lateral movement of the arm, wrist movement. And also gripping, and twist, and wrist twist. And also, so basically the way that we convert our human motion to a robotic motion is through variable resistors, through potentiometers at all these different points, controlled by the human, and then the microcontroller basically sends the analog signal, converts it to digital, and almost instantaneously converts it. Your human movement is mimicked by the robotic hand.
We also took into account that different users would be using it, so we made the actual control adjustable. As you can see here, you can actually adjust the size of the forearm, and here you can adjust the size of the bicep, so you can accommodate all types of users. And other than that, I guess everything else was basically explained.
Yeah, like we made this base, and we also we prided ourselves on this project to like not have any store-bought parts. So I mean, we built this from the ground up, from Home Depot scrap metal. I mean, aluminum plates, aluminum tubes, plexiglass. All that we really used was like the motors themselves, and we just like built everything from scratch. So like we're really proud of that, and the arm schematic as well. So like, we're really proud of that.
Nice.
As you can see, basically the robot mimics his movements. And also on top of that, whatever the robot grabs, as soon as it grabs something, it's going to limit his motion.
Right here?
Basically,
right here.
It's not allowing him to press anymore because the robot is actually touching something.
I feel pressure from this. So if I let go, that will happen. So let me just grab one more time. So you can see the flexibility. I'm going to squeeze. And if you let it, if you want, let it go. See now, look, if I squeeze all the way, it will just let me squeeze because there's not enough. See, look, he's gonna mimic like an object. So I'm just gonna squeeze until as much as I can, and look, you see, I'm stopped. But the moment he lets go, I can keep going.
Drop the object. Let it go.
It's a little bit limited because we have at the last minute this servo broke. We had to change it, but we're enough for presentation.
If you want a better product, you can fund this always. So, hi. Say hi to the camera.
Go like that.
Bye bye.
There you go.